The Software Assurance Technology Center, or SATC, plays a vital role in the realm of software assurance. As a trusted resource, SATC focuses on improving the security and reliability of software systems, especially in critical infrastructure. Its work centers on research, development, and collaboration to advance the field of software assurance. SATC's efforts contribute significantly to enhancing software quality and bolstering cybersecurity across various sectors. The mission of SATC revolves around identifying and mitigating software vulnerabilities that could potentially impact national security and critical infrastructure. The center achieves this by fostering collaboration between government agencies, industry leaders, and academia. Through this collaborative approach, SATC facilitates the development and adoption of best practices, tools, and techniques in software assurance. The significance of SATC's work lies in its focus on proactive measures to enhance software security. By addressing vulnerabilities early in the software development lifecycle, SATC aims to prevent potential exploits and cyber attacks. This proactive approach is crucial in today's interconnected world, where software vulnerabilities can have far-reaching consequences. Through its dedication to research, development, and collaboration, SATC plays a pivotal role in strengthening software assurance practices and bolstering the resilience of critical infrastructure against cyber threats. Its contributions have a direct impact on improving the overall security posture of software systems, ultimately contributing to a safer and more reliable digital landscape. As software quality models provide a structured framework for assessing and improving the quality of software systems. These models define a set of characteristics, attributes, and metrics that collectively represent the desired qualities of a software product. By adhering to these models, organizations can establish a common understanding of software quality and implement systematic approaches to ensure its achievement. Software quality models are essential for several reasons. Firstly, they provide a common language and a shared understanding of quality among stakeholders, including developers, testers, project managers, and customers. This shared understanding facilitates effective communication and collaboration throughout the software development lifecycle. Secondly, software quality models offer a structured approach to quality assessment and improvement. By defining specific quality characteristics and metrics, these models enable organizations to measure and track the quality of their software products objectively. This data-driven approach provides insights into areas where improvements are needed, allowing for targeted interventions to enhance software quality. Moreover, software quality models promote consistency and repeatability in software development processes. By adhering to established models and standards, organizations can establish standardized practices that ensure a certain level of quality across projects. This consistency is crucial for building a reputation for delivering high-quality software products. In conclusion, software quality models are indispensable tools for organizations striving to develop and deliver high-quality software systems. They provide a common language, a structured approach to quality assessment, and a framework for continuous improvement, ultimately contributing to enhanced software reliability, customer satisfaction, and business success. Numerous software quality models have gained recognition and adoption across industries, providing valuable frameworks for assessing and improving software quality. One such widely recognized model is ISO 9126, an international standard that defines a comprehensive set of software quality characteristics. ISO 9126 categorizes software quality into 6 main characteristics: functionality, reliability, usability, efficiency, maintainability, and portability. Each characteristic is further broken down into sub-characteristics, providing a granular framework for evaluating software quality. For instance, functionality encompasses sub-characteristics such as suitability, accuracy, interoperability, and security. Another notable software quality model is the Capability Maturity Model Integration, or CMMI. CMMI focuses on organizational maturity and process improvement, aiming to enhance software development and delivery capabilities. It provides a staged framework that organizations can use to assess their maturity level and identify areas for improvement. The Software Quality Assurance, or SQA model, another important model, emphasizes the role of quality assurance throughout the software development lifecycle. It outlines various quality assurance activities, including requirements analysis, design review, code inspection, testing, and defect tracking to ensure the delivery of high-quality software products. These industry-standard software quality models provide valuable guidance and best practices for organizations to assess, measure, and improve the quality of their software systems. By adopting and implementing these models, organizations can establish robust quality management systems, enhance software reliability, and meet the evolving needs of their customers. While specific named models attributed to SATC might not be widely publicized, their expertise likely translates into unique approaches and contributions to the field of software quality, particularly in cybersecurity and critical infrastructure protection. Given their focus, it's plausible that SATC develops internal quality models, frameworks, or guidelines tailored to their specific needs. Considering their role, SATC's potential contributions could take several forms. They might develop specialized quality attributes and metrics that emphasize security considerations, particularly relevant to critical infrastructure. These attributes could focus on aspects like resilience to attacks, secure coding practices, vulnerability management, and data integrity. Furthermore, SATC could contribute by adapting existing quality models to the unique challenges of cybersecurity. This might involve extending traditional models like ISO 9126 or CMMI with security-specific practices and considerations. For instance, they might integrate secure development lifecycle methodologies or threat modeling techniques into existing quality assurance processes. Collaboration is a cornerstone of SATC's approach, and this likely extends to their work on software quality. They could be involved in developing industry-wide best practices and guidelines for secure software development, working alongside other organizations and experts to define standards for secure coding, vulnerability disclosure, and incident response. While specific details about SATC's internal models may not be publicly available, their expertise and focus strongly suggest a significant contribution to advancing software quality, particularly in areas crucial for cybersecurity and critical infrastructure protection. Their work likely involves tailoring existing models, developing specialized attributes, and fostering collaboration to establish best practices that enhance the security and reliability of software systems. In the realm of cybersecurity and critical infrastructure protection, traditional software quality models often require tailoring to address the unique challenges and heightened risks associated with these domains. Security breaches in critical infrastructure can have devastating consequences, making robust software assurance paramount. SATC likely plays a crucial role in adapting and extending existing quality models to meet these specific needs. For instance, they might incorporate security-focused attributes into models like ISO 9126. This could involve adding new subcharacteristics related to security, such as resilience to attacks, secure communication protocols, and data encryption standards. Moreover, SATC might develop specialized metrics and measurement techniques to assess the security posture of software used in critical infrastructure. These metrics could focus on factors like the number of vulnerabilities discovered, the time taken to patch critical vulnerabilities, and the effectiveness of security incident response procedures. Furthermore, SATC's expertise likely extends to integrating security considerations into the entire software development lifecycle. This could involve advocating for secure coding practices, implementing rigorous security testing methodologies, and establishing robust vulnerability management processes. By tailoring existing quality models and developing specialized approaches, SATC contributes to a more secure and resilient infrastructure. Their efforts ensure that software used in critical sectors meets the highest security standards, mitigating risks and safeguarding national security interests. SATC's commitment to enhancing software assurance likely involves promoting and incorporating best practices and methodologies into their work. These practices, often derived from industry standards and research, provide a framework for developing secure and reliable software systems. One such practice is the Secure Development Lifecycle, or SDL, which emphasizes integrating security considerations into all stages of software development, from requirements gathering to deployment and maintenance. SATC might advocate for SDL adoption, providing guidance and training to organizations involved in critical infrastructure software development. Another crucial aspect is secure coding practices. SATC likely promotes adherence to secure coding standards and guidelines, such as those published by organizations like OWASP, the Open Web Application Security Project. These standards provide developers with best practices to prevent common software vulnerabilities and write secure code. Furthermore, SATC's approach likely emphasizes rigorous testing methodologies, including penetration testing and vulnerability scanning. These techniques help identify and address security weaknesses in software before deployment, reducing the risk of exploitation. By incorporating these best practices and methodologies, SATC contributes to a culture of security consciousness within the software development community. Their efforts help ensure that software used in critical infrastructure is developed with security in mind, reducing vulnerabilities, and enhancing overall resilience. SATC's focus on software assurance directly contributes to the protection of critical infrastructure, which underpins essential services and functions within a nation. Critical infrastructure sectors such as energy, transportation, healthcare, and finance rely heavily on software systems for their operation and management. Given the interconnected nature of critical infrastructure, software vulnerabilities in one sector can have cascading effects on others. For instance, a cyber attack on the power grid could disrupt transportation systems, healthcare facilities, and financial institutions, leading to widespread chaos and economic damage. SATC's expertise in software assurance helps mitigate these risks by promoting the development and deployment of secure and resilient software systems within critical infrastructure sectors. Their work ensures that software used in these sectors meets the highest security standards, reducing the likelihood and impact of cyber attacks. Through collaboration with government agencies, industry partners, and academia, SATC facilitates knowledge sharing, technology transfer, and the development of best practices specific to critical infrastructure protection. Their efforts contribute to a more secure and resilient infrastructure, safeguarding essential services and protecting national security interests. SATC's contributions to software assurance have a significant impact on the field, particularly in areas related to cybersecurity and critical infrastructure protection. Their work influences industry practices, government policies, and academic research, shaping the future of software security. One notable impact is the promotion of a culture of security consciousness within the software development community. SATC's advocacy for secure coding practices, rigorous testing, and the adoption of secure development lifecycles raises awareness about the importance of software security and encourages organizations to prioritize it. Furthermore, SATC's research and development efforts contribute to the advancement of software assurance technologies and methodologies. Their work might involve developing new tools for vulnerability detection, creating innovative approaches to security testing, or exploring emerging technologies like artificial intelligence for software security. Moreover, SATC's collaboration with government agencies helps shape policies and regulations related to software security. Their expertise informs the development of standards, guidelines, and best practices that organizations must adhere to, ensuring a baseline level of security for critical infrastructure software. Through these multifaceted efforts, SATC drives positive change in the field of software assurance, fostering a more secure and resilient digital landscape for critical infrastructure and beyond. In conclusion, while specific internal quality models developed by SATC might not be publicly available, their expertise, focus on cybersecurity, and dedication to collaboration strongly suggest significant contributions to the field of software assurance. Their work likely involves tailoring existing models, developing specialized attributes, and fostering industry-wide best practices to enhance the security and reliability of software systems, particularly in critical infrastructure. SATC's impact extends beyond specific models. Their efforts influence industry practices, government policies, and academic research, shaping a more secure digital landscape. Through collaboration, research, and advocacy, SATC plays a vital role in advancing software assurance, ensuring that software systems are developed and deployed with security as a top priority. For a more in-depth understanding of SATC's contributions and to explore their latest research and publications, visiting their official website or reviewing their publicly available materials is recommended. Their work provides valuable insights for anyone involved in software development, cybersecurity, or critical infrastructure protection.